You ready, Sophie? Yeah. Okay, so today, be able to calculate unknown angles in triangles and quadrilaterals. So, you've been working on the parallel line stuff. In fact, we've already done work on the triangles. You already know one of the things.
Oh, yes.
So, for instance, we know that in any triangle, we have three angles, right? And angles A, B, and C. And if I do A plus B plus C, so
180.
B, I get 180. 180 degrees. Okay? Now that's true for any triangle at all. Right? So, for instance, if we have a triangle, right? And I write in, I say this one is 50 degrees and this angle is 30 degrees. This angle that's missing, okay, if I say x, we could say x will equal
100.
Oh no, x will equal
100.
So we can say
100, yes.
50 plus
Plus
30
30
plus x should equal
180.
180 degrees. So
And
50 plus 30 is 80.
180 minus 80 is 100.
Now, just to ask you a question, how do you know my diagram is wrong and it's just a sketch? And I would say not to scale. How do you know that my diagram is just a sketch and not real? Nico?
Because the angle 50 is the wrong. It should be more open.
Well, it's kind of that. That's not a massive problem.
And then
But if you think 50, 30, but what's the real problem?
number 100.
Okay. Jenny, what were you going to say?
You check with a protractor.
No, we wouldn't check with a protractor. There's some other reason I know.
Number
It's kind of what Nico was saying.
number 100. It's to
But I
100, if
I-
that's 100 degrees, what kind of angle is 100 degrees?
Obtuse.
Right, good.
Also, it has to be bigger.
Exactly.
What
so it
I
should
thought-
be an obtuse angle. But in my diagram, this is an
acute.
acute angle. So, does that make the calculation wrong?
No.
No,
No.
because you
It's
did
good.
the sum correct.
Yeah, exactly. The sum bit was correct. The drawing itself is not correct. But if I say not to scale, that's how I get away with it.
I thought the answer was because you didn't draw exactly along the line. At the bottom.
No, it can be rotated anyhow I like.
Okay.
Just because I move a triangle around doesn't mean it changes its angles. Okay. So, but that's it. It's 100 degrees should be an obtuse angle, but I have drawn an acute angle. But as long as you realise that it's the calculation that matters, not my drawings as such. Okay.
But if you have to be really precise, it does count, right?
If I ask you to construct a triangle with the angles exact, yes, it would be, obviously that would be wrong, but that's the thing. For this topic that we're doing here now, right, there's one big thing here that we must do. So we are not measuring angles. We're not measuring. We are calculating angles. So the diagram itself doesn't really matter. It's just a guide to show us. We're not measuring. We don't need to use the diagram to actually do the measurement. We're just using it to do a calculation. Okay. Right. A couple of things we need to also consider. Right. So, if I were to draw a triangle like this, and I would tell you, let's say that's 32 degrees, and I ask you to find y there, okay? how would you do it? What's important to know? You wanna say something?
This one.
Here?
Yeah.
Yeah.
90.
So we know, even though there's no number, that square means it's
Oh,
90 degrees. Okay. So it's
And
gone.
sorry. And
Go on, you were
then-
gonna say?
Oh, and it's because it's in a right angle, and right angles are always 90 degrees.
Exactly. So, but if it had a curved line, don't assume it's 90.
No, it's not.
Okay. It's only 90 if it's a square like that. Right? If you see this, okay, like that, we don't assume it's 90 degrees. Okay, don't assume it. Right? If it's a square there, we can assume it's, well, we know it's 90 degrees. So the same thing applies to solve this problem then. We've got 90 plus 32 plus y would equal 180 degrees.
58.
90 plus 32 is 122. So we know that y must be
58.
58. It's always a good tip to write it on your diagram, okay, just in case you've got further questions to do. Alright, do you want a chance to write that down?
Yes, please.
Right, so after these diagrams then, we've got just a couple more things that we need to know about with our triangles. And what we have is this notation here. So I draw this triangle.
Oh, it's
Right. Angle. Okay. I say that. So what do I do? 27. No, not really. 28 degrees. Sorry, I should read that. 28 degrees. So it doesn't look quite right, but 28 degrees. And I'm going to put two lines here and here. And I'm going to ask you to find the angles A and B. Now you know that A plus B plus 28 equals 180. But there's a problem, because when two numbers are not known, it could be anything. But what do we know about this triangle? Jada?
It adds up to 180.
Yeah, we've got that. It adds up to 180, but A and B is two angles that we don't know. So
It's an equilateral triangle.
it's not equilateral, but you're close.
Oh, which means all sides.
It's an isosceles.
Oh, it's an isosceles.
It's an isosceles triangle. Now what does that
Oh.
mean?
When two sides are longer than the other one, when two sides are the equal length, and then the
Right,
third
so
one
it's-
is not.
It's when the two sides are the equal length. Now that's why these two little lines are here. Okay? The two lines mean those two sides are the same length. Now there's one very important thing about that helps us with the angles. If the two sides are the same, we
The two angles
also
are the
know
same.
the two angles are the same. So we can also say that A does equal B. So these two angles, okay, are the same angle. So that helps us work it out.
To work out those two angles, would you say 180 minus 28 is, I know this is 160,
No.
152, sorry.
Yeah,
And
150.
then 152 divided by 100 is,
No, not quite. But it's 150.
divided by 2, sorry.
Exactly.
Sorry.
So 152 divided by 2 because it's
so-
shared between these two angles.
100 divided by 2 is
It's
50, 50 divided by 2
71.
is 30, 25, sorry.
Yeah.
And 2
And
is
one.
1, so
So it's 100 plus 25 plus
25.
1.
26.
So it's 100 and
26.
20. So it's not 26. So 100 divided by 2 must have been 50. Yeah. 50 plus 25 plus 1 is what? 76 degrees. So we know that this angle and this angle, they're both 76 degrees because it's an isosceles triangle. Right.
And there's a scalene.
So scalene triangle was what we drew further up here,
Where all
where
sides
all
are
the angles are different. So this would have been a scalene triangle, you're right. So we've got scalene, we've got a right angle triangle as here, where we know the right angle is 90 degrees, right angled triangle.
And yeah,
We've looked at an isosceles triangle and how we can use that to solve our problem. We've got one final type of triangle, which is
what's
the
the
one that you
name?
mentioned
I
earlier.
can't remember.
Yes, wait, I know it. It's
Equilateral.
equilateral
Yeah.
because it's equal.
Exactly. An equilateral triangle. Now, if an isosceles triangle had a little line to represent two of the sides with the same length, what do you think we do with an equilateral triangle?
All sides and the length.
All the angles are the same, which means you just do 180 divided by 3.
Okay, you've skipped a thing, but you are right. So all the angles are the same, right? So we can do 180 divided by 3 equals 60 degrees. So in every equilateral triangle, every single one, it's always 60 degrees, 60 degrees, 60 degrees. And the little notation that we can see to know that it's an equilateral triangle is if we put a little line through each side, all three sides. So if you see that little line, that means all three sides are the same, all angles are the same, and they're all 60. It's an equilateral triangle. Okay? Got it? Right. So, using that information then, I'm going to ask you to turn to page 25, and you are going to do exercise 2B.
Can you finish this?
No, we'll move on from our.
Can you move up a bit, please?
Okay.
Thank you.
Right. So recording again. Question 3. So question 1, we thought, okay, they just add up to 180. Yeah. Okay. Question 3 though deals with this situation. We're all paying attention now. So I'm going to draw a triangle. Okay. Well, you don't have to. What I'm going to do, I'm going to draw a triangle, but this line is extended. Right? Now, this is what happens in question 3. They've done more. So if I say to you, this angle here is 50 degrees. This angle here, let's say, is 64 degrees. Okay. What can you work out? So you can work out this angle in the triangle, yeah? Yeah? Do you know what it is? Sophie? 50 plus 64.
54 is
114. 114.
Calculator, it's cheating. Go on, Sophie, you do it in your head.
100.
Actually, no.
Wait, 50 plus 60 is. Oh, 114.
Yeah, perfect, well done. 114 degrees. This one has to add up to 180, so if we do 180 minus 114 gives me
100. No.
60.
6.
66, good. So this one's 66. Now, here's the other thing.
Oh, I get.
If I ignore the triangle and I look at just these two angles, what do those two angles add up to?
180 because it's a straight line, so you do 180 minus 66.
Exactly.
I get this.
So imagine if I ignore the rest of the triangle, imagine I've got that line and then this line cuts it in half. So this side, if that side is 66, this side must be
114.
114, which is the same as the other two added together. Okay?
So you don't even need to So like
It's in all of them, but they add together.
So, because those 3 add up to 180, and those 2 add up to 180, it makes sense that those 2 and that one must be the same. Okay?
So that means you don't even need to calculate where the...
So you don't need to calculate that
yeah,
one at
you
all.
just add those together and then that's
Perfect, yeah, spot on. Yeah, well done.
So for 3A, it would be... Wait,
136.
94 plus 42 is 9, 10, 11, 12, 13. 100...